Cold weather has been persisting over the eastern parts of Europe in the first weeks of the year. The extended snow cover helped at keeping the initial core of cold air in the temperate zone, unlike similar situations in previous years when the lack of snow led to a rapid evacuation of cold air from the continent. This pattern seems to take a break from dominating the weather as the zonal circulation restarts. However, this may only be applicable for half of the continent. As we can see, the western Atlantic coast is preparing for a very stormy week. Many cyclones will impact the United Kingdom, Ireland, France and most of Portugal and Spain. The winds will generate problems, with gusts constantly exceeding 100 km per hour, especially in the coastal regions. The most affected area seems to be the Gulf of Biscay. The reason for this lies in the formation characteristics of the cyclonic pattern. An anticyclonic core arrives from over the United States and merges with the pre-existing Azores High. In its way, it drags very cold polar air over the warmer waters of the North Atlantic Gulf Stream. This confluence leads to a very organized cyclogenesis. At the same time, proeminent Rossby waves formed over the ocean create a deflection in the normal west to east movement of the cyclones, causing them to suddenly take a northwest to southeast trajectory. The temperature contrast between the polar air that is dragged over the ocean and the air it meets also leads to good amounts of precipitation being discharged. Northwestern Spain and Portugal will be the most affected by heavy rains, but most of the coastal regions should expect important rain accumulations. While moderating the temperatures, the cyclones will still bring chilly air, and, with winds being constantly high, the real feel of the temperature will be pretty low. The effective temperatures will stay around normal climatological averages for France and the British Isles. In Portugal, Spain, and Western Mediterranean basin, the temperatures will stay below those averages, as those regions are used to warmer weather. The eastern half of the continent is quite different from what we've seen for the western parts. Very cold conditions are still a day basis eastward of Germany and Austria, with even northern Italy experiencing a colder than normal January so far. Starting Wednesday, the polar air mass will begin to be ventilated away, with the western regions being the first to feel a warming trend. Nights will still find most of those places within negative temperatures range, but during sun hours, temperatures will rise to about 10 or even 15 degrees Celsius in lowlands across the Balkan Peninsula. Belarus, Ukraine, the Baltic states and the northeastern parts of Germany and Poland will remain under the influence of a colder air. Beginning Friday, this cold air will be again pushed westwards, from what it seems. It is uncertain yet if this push will again reach countries like Serbia, Bulgaria, even Romania. A more likely scenario shows that the warm air will remain above those regions, in the end. All of this back and forth transportation of cold air masses is related to the continuous presence of an Ural-blocking anticyclone that tends to push westward, but is met by the strong Atlantic cyclones. While continuous cyclones affecting the western coast of Europe may seem like a normal scenario for the normal west to east circulation, if we take a wider approach on what the situation looks like, nothing really normal can be seen. Firstly, it is obvious that the high-pressure systems, which are colored in red, are extremely extended over the visualized area. In comparison, the low-pressure zone, made up of cyclones, occupy a significantly smaller portion of the whole region. This contrast can provide valuable clues about the polar vortex's state. At this time of the year, under normal conditions, the polar vortex should dominate the polar and circumpolar regions, as a whole low-pressure system, fueled by temperate cyclones. The only strong high-pressure zone functioning within this structure should be found close to the North Pole, as a polar anticyclone formed by the earlier uplifted air that is now descending. However, this is clearly not the case for these days. Large areas that normally should have constantly been directly under the influence of low-pressure systems are now experiencing anticyclonal weather patterns. In this situation, we are talking about a weak polar vortex, which is unable to function under normal conditions, after being degraded by different factors, such as the strong solar radiation, global warming or a weak structure inherited from the formation phase. A weak polar vortex may bring cold weather at low latitudes, as we saw for the first half of January, but this transportation comes at a great price in the context of a warmer atmosphere. The polar air advected southward often displaces the warm air from those regions and causes it to take its place at higher latitudes. The result is very damaging to the polar ice sheet, which, with temperatures close to 0 degrees Celsius, cannot consolidate. It is very important for us to understand that the climate system tends to develop a compensating mechanism. This is translated to some regions of the planet getting much higher temperatures than normal, while some others are constantly under cold spells. Those extremes may resolve the imbalances per total, but are surely not beneficial for human activities and even nature's processes. Global warming can also mean much colder periods, as Europe experienced in those weeks, but different from the past. Cold air advancing south comes at high costs for the fragile polar regions.